Hello everyone, myself Dr. Sonam Gupta, working as a professor in the Department of Computer Science and Engineering. Today I am going to discuss a complex topic in software project management, which is managing the risk. Now, first one, we are going to discuss the risk, but before that we need to identify the activities and how these risks can occur and what will be the outcomes for it. So, activity planning, it is also the project management plan preparation, and it is known as Software Project Management Plan, which is SPMP. The objectives of activity planning is feasibility assessment, resource allocation, motivation to the team, effective utilization of human resources, effective time management, project costing, project tracking, and RMM activities. Now, time is nature's way of stopping everything happening at once. So, having worked out a method of doing the project, identifying the task which needs to be carried out, and accessed the time needed to complete each task. We need to allocate the dates and the times for the start and end of the activities. And from there comes the risk. Now, in risk management, we will be discussing definition of the risk management, what are the various ways to categorize the risk management like identification, analysis, planning, monitoring. So, identification is what are the risks to a project. Analysis, which one risk are really serious, which needs to be taken care of. Risk planning, what shall we do? Risk monitoring, has the planning worked or not? So, along with this, we will also look for the critical PERT risk and the critical chains. So, there are various definitions of risk. First one, it is the chance of exposure to the adverse consequences of the future events. Now, project plans have to be based on assumptions. And what is the risk? Risk is the possibility that an assumption has gone wrong. When the risk will happen, it will become a problem or an issue as well. Now, there are various categories of risk. We are having actors, structure, task, and technology, and all these things are going hand in hand. They are very much connected to each other. Now, for the planning of the risk, we have 3 steps: risk identification, analysis and prioritization, planning and monitoring. Now, identification is what risk can be there. Analysis and prioritization, which are the most serious risks. Planning, what are we going to do about them? And monitoring, what is the current state of the risk. For the risk identification, the approaches to identify is use of the checklist. Now, it is based on the experience of the past projects. So, the checklist can be created only if we are having the experience about the past projects. Brainstorming sessions can be there, that is getting knowledgeable stakeholders. Causal mapping, it is identifying possible chain of cause and the effects. Now, there are BOEM's top 10 development risks. First one, personal shortfalls like staffing with top talent, job matching, team building, training and career development, early scheduling of the key personnel. Another risk can be unrealistic time in the cost estimate. Now, how this can be reduced? Multiple estimation techniques can be used, design to cost, incremental development, recording and analysis of the past projects, standardization of the methods. Third is developing the wrong software functions. Now, how this can be reduced? Improved software evaluation, formal specification methods, user surveys, prototyping, and early user manuals. Next is developing the wrong user interface. So, how it can be improved? By prototyping, task analysis, and user involvement. Next is global plating. For that, it requirement of scrubbing, prototyping, and design to cost. For the late changes to requirements, change control and incremental development. For shortfalls in externally supplied components, benchmarking, inspections, formal specifications, contractual agreements and quality controls. For shortfalls in externally performed tasks, quality assurance procedures, competitive designing, all these can be done. Real-time performance problems, simulations, do the prototyping, do the tuning. Development technically too difficult, so technical analysis, cost benefit analysis, prototyping and training. So these are the few risks and few methods has been suggested to overcome those risks. In a way, we can identify more other risks and other solutions as well. So like for the causal mapping, we are having low staff turnover high. So we can have experienced staff or inexperienced. So it can lead to high productivity and low productivity. Deadlines can be met, it is missed. So this is how the causal mapping is done. We are having low staff turnover. So what will be there? They will be inexperienced, they can be, productivity can be low. But if we are having high turnover staff, they will be experienced staff, productivity will be high. So this is how the causes and effects can be shown in a mapping stage as well. So interventions are like we are having actors, technology, task and structure, as we had seen earlier also. They are very much connected to each other. So if we are able to identify any of the type of risk in any of the module, then it is going to affect the other module as well. Like if there is any risk in actors module, then it is going to affect task, technology, structure as well. For risk prioritization, we need to calculate risk exposure. Now, what is risk exposure? It is potential damage multiplied by probability of the occurrence. Now, let's consider a case like we are having a potential damage. A money value like a flood, it would cause $0.5 million of damage. The probability is 0, that is no chance to 1, absolutely certain. Like we are having 0.01, that is 1 chance in 100. So risk exposure will be 0.5 million multiplied by 0.01, that is to be 5,000 pounds. So crudely analogous to the amount which is needed for an insurance premium. So that is how insurance premium can also be calculated. Risk probability, it is a qualitative descriptors, like probability levels can be various probability levels can be there, like high, greater than 50% chances of happening. If the probability level is significant, that means 30 to 50% chance of happening. If the probability level is moderate, that means 10 to 29% chance of happening. And if the probability level is low, then less than 10% chances of happening will be there. Now, how these ranges will be identified? If the impact level is high, then greater than 30% above budgeted expenditure will go. If it is significant, then 20 to 29% above budgeted expenditure. Moderate, it means 10 to 19% above budgeted expenditure. And if we talk about low, that means within 10% of budgeted expenditure. So, while calculating the budget also, we need to identify what are the risks there. Then, depending on the risk, we need to identify its impact level, because the impact of the risk will play a major and a crucial role in identifying the budget of the project as well. So, as can be seen in this graph, we are having probability and the impact. Like tolerance line is there, this is the tolerance line. That means beyond this tolerance line, if any of the risk will affect, then it is going to affect the whole project drastically. So R6, R1, these are the few risks that are falling above this particular tolerance line. R2, R3, R5, they are having a significant impact and the probability of occurrence is moderate. For R4, probability of occurrence is high and the impact is moderate in nature. But R6, the probability of occurrence is moderate and the impact is also high. Similarly, R1, which is of the more danger zone, the probability of occurrence is also high and the impact is also very high. So, it needs to be taken care of very crucially. So, risk planning, it can be deal if we have risk acceptance, risk avoidance, risk reduction, risk transfer, risk mitigation, or we can have the contingency measures as well. For risk reduction leverage, it can be calculated risk exposure before minus risk exposure after divided by cost of risk reduction. Like risk exposure before, it is example like 1% chance of fire causing 200k pound damage. Now, risk exposure after, it is the risk exposure after the risk reduction, like alarming cost, it is causing just 500 pounds. It is reducing the probability fire damage cost to be 0.5%. So, what will be the RRL? RRL will be equal to 2. So, if RRL is greater than 1, that means the particular measure that we are going to take is well enough. We can go for it. It is worth doing. Now, this is the probability chart. We are having this and the percentage of probability completion. So, number of days means how many days it will take and what will the probability of completion for that particular task or for that particular risk. So, this chart can be used to identify the risk and to take proper measures for that risk as well. Now, to calculate the effects or to evaluate the effects of uncertainty, we can have the use of PERT chart as well. So, for this PERT chart, we are having three terms, M, A and B. M is most likely time, A is optimistic time and B is pessimistic time. Now, to calculate the expected time, that is TE, it will be A plus 4M plus B by 6. And along with this, we can also calculate the standard deviation. What is standard deviation? Standard deviation is B minus A by 6. So, we are having a chain of the activities like task A, task B, task C, and from here, from this chain of the activities, we can see that the result of task B will be given as input to task C. The result of task A will be given as input to task B. So, we are having all these tasks, we are having A, M, B values for this. We need to calculate the expected time and the standard deviation. So, we can easily do that by using the formula. So, for that, if for chain of the activities, answer will be 48.65, and if we calculate the standard deviation for A plus B plus C, so that will be the square root 1 square plus 1 square plus C square, that will be 3.32. So, thereby we can calculate these values as well. Now, we need to assess the likelihood of meeting the target, that whether the target will be met or not. So, like we say, the target for the completing A plus B plus C, it was supposed 52 days. Now, we calculate Z. So, for that Z, it will calculate by T minus TE by S. So, we have the value of TE, we have the value of S. We just need to put these values in this formula, and example, Z value came out to be 1.01. Now, from here, we can see the value from this chart, we can easily see Z value, it is 1.01. So, it will fall nearly behind this. So, we can easily have graph for the Z values, and then we can see what is the probability of meeting that particular target. So, thereby we can see that whether that particular target will be met or not, and if yes, then what is the probability of meeting it through this graph. Next is Monte Carlo method. So, Monte Carlo method, it is a numerical method for statistical simulation which uses sequence of random numbers to perform the simulation. Now, for this Monte Carlo simulation, it is a versatile tool which is used to evaluate and analyze the complex measurements. We can also say that it is a method to construct a model of a system. Now, experimenting with the method to draw the inferences of the system's behavior, that is the meaning of this particular Monte Carlo simulation. For this simulation, we are having inputs. What are the inputs? Inputs are the decisions and uncontrolled variables which are not in our hands. Then we go for the simulation model. This is Monte Carlo simulation, and then these outputs are performed. So it will measure the behavior of the system under these uncontrollable variables environment, and thereby the output will be generated. The model, it inputs and captures the environment of the problem. Now for the simulation model, we are having a conceptual model. For this conceptual model, it is set of assumptions that will define the system. We are having a computer code, that is the implementation of this conceptual model that will be done. Now the output, it will describe the aspects of the system behavior in which we are interested. Now there are various project constraints as well, like technical or logical constraints. So constraints, they are related to the networked sequence in which the project activities must occur. Physical constraints, activities that cannot occur in parallel or are affected by contractual or environmental conditions. Resource constraints, these are the absence, shortage or unique international ship or interaction characteristics of resources that are required for a particular sequencing of the project activities. Now, these projects can be classified as well, like time constraint project. Time constraint project in which date is very important. A project that must be completed by an imposed date. So, we are having time is fixed, resources are flexible. Additional resources can also be used to ensure that the project will meet its schedule. Next is just opposite of it, resource constraint project. That means in a project, the resources, they cannot be exceeded. So here what is there? Here the resources are fixed, but the time is flexible. But here inadequate resources, it will delay the project. So that is the another concept for this project. Now, what is the impact of resource constraint scheduling? So, resource reduces delay, but it is reducing the flexibility as well. Increases criticality of events, increasing scheduling complexities, may make traditional critical path no longer meaningful. It can break sequence of events as well, and it can cause parallel activities to become sequential, and critical activities will slack to become non-critical. So, these are the few impacts of it. Assigning resources to the task. So, don't always pick the same people for the toughest assignment. This is the one thing. Choose people with an eye to fostering development through participation on the project. Pick people with compatible work habits and personalities so that they can complement each other. Team of veterans with new hires to share up experience and socialize in the organization. Select people who may need to learn, work together later stages of the project or the other. So, by the help of all these things, by reducing the risk, by identifying the project to a major task, by allocating the resources, in identifying how the resources will be manipulating each other, how these time constraint, resource constraints will be worked, how to calculate the probability, the risk factor, all these things we have discussed in this particular lecture. We have also seen the PERT chart, how this PERT chart is going to play an important role to calculate the Z values from that Z graph. We have also explored risk exploration, risk prioritization, and all other moderate, significant, most likely things in this particular lecture. So, by the help of identifying all the risk, we can have a major budget, because what is the end thing which will come to the scene is the budget. If we are not capable of identifying the risk and identifying that what will be the impact of that particular risk on the project, then the project is going to be hampered very badly. So, for that, risk needs to be identified and all the major scheduling part that needs to be done properly. Thank you.